Awesome. I'm going to get started. Hi, everyone. My name is Nitya Narasimhan. I'm a senior AI advocate on the developer relations team at Microsoft. But I'm actually here today because I want to get you excited about learning data analysis and visualization, even if you're not a Python developer or a data science expert. So before I get started, though, let me actually share a link. So if you can, feel free to go grab this link and bookmark it, or you can fork the repo right now. We're not going to be able to obviously go through the whole repo right now, but what I will be doing, and I'll share the link at the end of the talk, is releasing a series of 7 posts starting tomorrow, where we will have a tutorial for each one of these, one a day. So my goal today is really to get you excited about wanting to go and explore this on your own. But we always have to start with this fundamental question, right? I mentioned that this is about jumpstarting a data analysis and visualization journey. But why would you do that if you're a developer? So why should you learn data analysis? Now, if you know about the whole kind of revolution that's happening in AI today, you probably know that everything starts with data. Data analysis drives machine learning models, which power AI algorithms, which are then driving these generative AI and predictive AI experiences. So if you're a data scientist, then data analysis and visualization is a must-have skill. But what if you're a developer? Trends are showing that there's been a shift left in this application cycle that you see here. This is the data science cycle at a very high level. And the shift left is because we're beginning to see things like responsible AI, where we really want to detect and mitigate harms very early in the development cycle rather than wait for post-production. And so if you pick this up as a developer, if you know the terms, technologies, the techniques, it's going to add value to you in your team. But if not, do it just because it's fun. So what stops you from learning? When you want to learn something, there's usually 2 things that stop you. One is what I think of as the knowledge gap. It's when you know you don't know something, but you kind of know how to get that knowledge. And usually developer tools help here. Like if you have the right tools, the right tutorials, you can get where you need to be. The hard thing is the intuition gap, because there are people who've been in this space for like decades. They know everything. How are you going to even meet that level of knowledge? You don't even know what you don't know. So where should you start? And this is where I want to kind of talk about how AI assistants can help you build your intuition. So the bottom line is you take just one thing away from this talk, because it's really targeted at beginners and people who haven't worked with any of these tools. I want you to think about this not just for data science, but for anything. If you want to learn to do something today, our old kind of like imposter syndrome is, I don't have the experience, I can't do this, right? But I want us to shift the mindset to, wait, you know what? There's developer tools to help me, and there's AI that I can ask. So where do I start? And so my whole goal today is really to give you a roadmap that tells you where to get started. But I want to say one more thing. We can't go into this wanting to boil the ocean. You can't come up with 10 years worth of experience in a day. So what we really want is to think about a development environment and a roadmap, which has 3 things. First, I want to make sure that this journey is frictionless. That means that when I get started, let me get productive really quickly. How many of you have been at these workshops where someone says, here's a tutorial, here's a prerequisite, get started, and you're like, it's not working on my Mac, and the person next to you goes, well, it works on my machine. That's a problem. We need to have the way to kind of like get past that hurdle of setup. Second is we want to keep it focused. Every time we want to learn something, what do? We go to Stack Overflow or Google, but what does that make of us, right? We're like, oh, let me Google this. You start looking, you get into this rabbit hole, an hour later, you don't have an answer, but you're reading something else. Instead, we want to be goal-focused. How do I keep my learning in the context of what I'm doing? I learn what I know, what I need, when I need it. And last but not least, let's make it friendly. And what I mean by this is that any environment I use, I want it to be shareable. I want it to be something that I can tap my friend and say, hey, I'm having this problem. Can you reproduce it and help me? Or maybe like, hey, I need this done, and I know you're good at this. Can you collaborate with me on this? So, right, we don't want to be in this place where we're like, I need to write notes and remember what I did so I can tell you. So if you remember that one thing, I kind of want to dive into this roadmap for what I want to talk about today. If I do my job right, I'll have kind of given you a sense of what tools you can have from start to end. And starting tomorrow, you can go dive into these hands-on. So let's first start with frictionless. I need a consistent development environment with easy setup. And you know where I'm going with this if you're familiar with the space. That's Codespaces. If you're not familiar with this, GitHub actually has a Codespaces Jupyter template that I hugely recommend. But if you fork my repo, you'll notice that I actually extend that template. And in my repo, there's a branch called Data Science Day 2024. If you do plan to fork it, make sure that you uncheck that little blue mark so that you're getting the version that's for this particular event and not the main branch. But my point is, whether you take this repo or you take that template, you're going to start with a template that has something called a dev container. And to run it, you simply drop the code blocks down, switch into the Codespaces tab, and say launch. And within seconds, in your browser, you will have a tab with a Visual Studio Code environment and your environment set up. That simple. You didn't have to install stuff. You didn't know nothing. You jump-started your setup really quickly. And if you're like me, because GitHub Codespaces does have a quota, and if you use Codespaces as much as I do, it kind of runs out. So you can also do the same thing on your local machine. Simply clone that repo to your local device and open it in Visual Studio Code. And if you install the dev container extension and you have a Docker desktop running, you will see a pop-up like that says, would you like to reopen this in container? Say yes, and you should see this. If you got this far, congratulations. You now have a development environment where you can start your data science journey and start playing with some of the ideas we'll talk about today. Now, I'm not going to do live demos because I've had enough issues today, but I will tell you that I am running that same environment here in Docker Desktop. So where possible, we'll keep switching back and forth to look at it, but I have screenshots just in case. So what this is doing for you is giving you a pre-built environment that works the same for everyone. You see the same thing that I do. But how does that work? Like, why is this important? So under the covers, dev containers, and if you remember one thing, remember this, it's configuration as code. What makes it awesome is that that configuration is actually defined in this one file called devcontainer.json. And it says, hey, please use this container image from Microsoft, which has environments for Python, Java, .NET, everything. And when you run this container, please go ahead and look at this requirements.txt file for all the dependencies I need you to install in it. And that's it. The beauty of this is that if I were to have a new requirement tomorrow, or if I want to add another, change my image, I just have to change that file. The next person who forks that repo is going to get that environment. They didn't have to do anything to upgrade. So what configuration as code does is it makes version controlled environments so everybody sees the same thing. So how does it work, cloud or local? There is a container that's running. If you're in GitHub Codespaces, it's running in the Azure cloud. If you're using Docker Desktop, it's running in your Docker Desktop on your device. And in that, there is a VS Code server. So your VS Code client can now connect to that server, whether it's from your browser tab or whether it's from your local VS Code. And now your VS Code environment, which is your editing environment, and the runtime are sharing a file system which contains your source. And if you're in the cloud, it's your GitHub repo. And if it's your local device, it's your clone repository. But effectively, you are now set up with a Visual Studio Code environment, a dev container, everything exactly the way you want it. Great, let's move on to the next thing. Our next problem is, I need this reproducible. If I want to share this with someone else, I need them to know what I did when I did it. Remember I told you we're using a Codespaces Jupyter template? Tool number 2 is Jupyter Notebooks. If you're not familiar with it, Jupyter Notebooks are an interactive environment that has code cells and documentation cells. So not only can you write your Python code, but you can write documentation right above it so you remember what you did. And if you were to have taken that Codespaces Jupyter template, as you can see here, it comes with these 3 things out of the box. 3 notebooks that you can use to get started on your journey. The first one is Matplotlib, and we're looking at it right here, which teaches you just the fundamentals of using Matplotlib, which is the most popular library for 2D data visualizations. So I'm going to switch over for a second. Demo gods, help me. This is what you do. I'm not doing anything at all. I grab the notebook. I basically set this kernel, and this kernel is Python 3 because my dev container is already set up to use it. And then I'm going to clear all this, and then I'm going to run all. And what this is doing is it's running this code for me in this notebook and showing me the output. I can go in and I can do things like change it. I can say, okay, let me add one more, rerun this, and it should change. So I can play with this interactively and run this environment. And again, no effort on my part. This particular tutorial teaches you very basic kind of functions from Matplotlib for plotting. But wait, there's another notebook you can look at, which is the second one on here for population.ipnb. We already did this part, so I'm going to look at this. So the second one, if I go look at that notebook over here, it looks similar because it's, let's clear this again and run it, but it looks similar because it's really just running, then kind of showing you how to visualize something, but there's something different. It's loading data from a file. And that is where we are introducing a second library called Pandas. Pandas is the second Python library that you really must know. It helps you with data manipulation, data gathering, cleaning, etc. And it'll work with other libraries like Seaborn and Matplotlib to actually help you visualize it. So you have an example there to get you started. And it's really simple. So what you can do in here is you can go in there and change that file. Just, this is how you learn. Go in and change the file name. To make your life simple, I've put a little data folder here with little data files. You're stuck with this file because I love Cricut. So you're going to learn more about Cricut than you ever knew. But you can bring your own CSV file if you want. Go ahead, change it, do nothing else. Change it and say, can you run this? And then change just the x-axis and values. You're experimenting as you go. And you'll see you get this crazy plot. You're like, well, the good news is I made a change and it worked. The bad news is I have no idea what this code is doing. So now we want to get to the next step. How do I build my knowledge? Like, okay, tools are going to help me get there, but I still need to know what I will have to ask them to do. This is where GitHub Copilot can help. So I think there are deep dive sessions coming up later today. So Copilot is a paid offering, but you can have a free trial to try it out. And what it's really doing, you can install it using dev containers or just add it on the fly. What it does is it provides AI-assisted explainers, debugging help, and etc. Under the covers, it's an LLM that knows how to do code completion and understands code. Just know that you can use it in two modes. Inline mode is where you open up Copilot on the right side inside a particular file. So it sets the context to that action that you're doing. And now you can use inline mode to ask it to explain something in there, fix a bug, etc. Or you can move into chat mode and say the context is the entire workspace I'm in. And I love chat mode because it has powerful features like allowing you to create new notebooks to help you learn. Remember, we just looked at Pandas. That looked nice, but it was like 2 lines of code. I want to know what Pandas does. So I'm going to go over to Copilot chat and say, hey, can you create me a new notebook that teaches me about Pandas usage? And when I hit enter, it created this. So if you go into my repo, you'll actually find, I think it's under, under Copilot here, actually. So it created this. This was the first one that I changed. And when I asked it to create me a notebook, it created this for me. It did everything. And now I can say, hey, I want to run this. And I've left it exactly the way it created it so you can get a sense of what it does. There will be errors, but it is beginning to give me some interesting stuff. But then there's an error. And I'm like, I don't even know how to fix it. So it references the file. You can go and play with it. See if you can figure out how to fix the error. But the most important thing that I want you to look at when you use Copilot is that every time you ask it a question, it gives you a suggestion at the bottom. And those suggestions are how you expand your intuition. Remember I was saying you don't even know what you don't know? Well, now you know what you don't know. So when you ask a question, it kind of is telling you, if you ask this, chances are there are these 3 things you didn't know about. You want to learn them as well. So I asked about visualizations. It says, do you want to know about this particular visualization? And if I dive into that rabbit hole, it says, do you want to know how to make that visualization? So build intuition by using Copilot as your inline coach. And remember, through this whole process, I never left. I never went to Google. Whatever I was doing it in a goal-oriented way, moving myself forward. And last but not least, it's also a great way for you to explore your expertise in prompt engineering. Remember, I'm still chatting. And that means that my result is only as good as the prompt that I give it. One of the value propositions of having Jupyter Notebook is you want to be able to document the prompt you used when you created these things. And then later on, you can come back and refine it. And every time you refine it and you learn something, you document it. Not only will you be building your own knowledge base, but tomorrow, if you're sharing it with a friend and asking them to debug, they can reproduce it. So great. Remember that it has markdown cells and code cells. So that's good, right? We're buzzing along. Oh my gosh, we've got a development environment. We've got an interactive runtime with documentation. I have somebody to help me answer questions. And by the way, I'm not going to depth because there are sessions that will take you into like details of how to use Copilot. But I know now I have somebody who can help me. What more? Well, remember that the dev container sets up your backend environment, your runtime. but it's still being connected to from a Visual Studio Code editor. Is there any way I can make my Visual Studio Code editor more productive for me and make it shareable, perhaps? If you don't know about Visual Studio Code profiles, now's the time for you to go look at them. A Visual Studio Code profile is yet another thing that you can check in. You can export it and check it into your code base. Somebody else can then import it into their Visual Studio Code to set the profile, and now you're both seeing the exact same editor experience. But what do I want you to do if you're starting off? Visual Studio Code profiles help you set the extensions, the settings, the preferences, your look and feel of your editor. But wouldn't it be nice if it kind of knew that for data science, I need certain things? Well, yes, there is a data science profile. When you create a profile, and you can see it at the bottom here, click the little gear, pick a profile, and say create a profile. And when you create it, you get choices. You can say derive it from the data science one, and I get a data science one. And part of that is a Data Wrangler extension. And that Data Wrangler extension, the minute I install it, within my notebook, I will now see a little button that says, do you want to open this data in Data Wrangler instead? And that opens it up in an extension. And there's a session later today that'll go into detail, so I won't go into detail here. But what it means is I'm seamlessly going from Jupyter Notebook into a Data Wrangler extension. In that extension, wow, look at this. It lets me say, hey, do you want to edit it? Why don't you tell me what operations you want to do to clean and fix the data? Interactively low code, and I will write the code for you. And you can apply it, see if that fixes it, and then if you want, you can take it back to your notebook. So this is brilliant. Now I have a really good environment. Like I've got everything. We're all done, right? No, we're not, because I'm showing you this with Cricut, and I'm sure a lot, like at least in the repo, it's Cricut. You don't know Cricut. Or maybe you want to like explore data science for a particular reason, like climate change. You want to understand how is carbon data, how to analyze and visualize that. Well, where do you start? So I want to talk to you about 3 resources where you can find open data sets. When I say open, I mean these are curated data sets that are publicly available. Doesn't mean open as in free. They will have licenses. Please pay attention and make sure that you attribute them. But the main thing in this is that you have sources that give you data science related data sets. Kaggle, everybody knows, is a great starting point. The most important thing for me in Kaggle is not only can I get a data set, but I can get community generated notebooks showing you how to analyze the data set that you can learn from. So in here, I keep talking about this Cricut data set. Well, I go to the community and someone's already built an exploratory data analysis notebook that I can use to understand, well, oh, that's cool. So this is how I do a pie chart. Is that right? Okay, this is how I do a stack chart with colors. So I can learn from them. Oh, wait, there's more. Not only can I find data analysis notebooks, I can find machine learning notebooks that use the model, that build models based on the data. So here, there's actually someone who's published a notebook that can predict Cricut scores using this data. So you see how we kind of use these resources to keep expanding our knowledge path? Second resource, Hugging Face. Now, Kaggle is great for like when you've got curated data sets, you're just starting off. But then you want to get into deep learning. You want to look at what's happening in the large language model space, perhaps. You want to look at different types of use cases. Hugging Face is an open source community, and they have a really huge collection of data sets curated by the community. But more importantly, they have a data sets library, and they have tutorials that can really, really help you get this done. And over the course of time, I'll be adding all of these dependencies with notebook examples into that repo. So keep an eye out for that. Last but not least, there is Azure. So if you've looked at those, but at some point you want to really think about production, you want to change your mentality from, hey, I'm working with community curated data sets to a big data mindset. How do I actually integrate this into pipelines? How do I take it from like this analysis into scale? And this is where Azure Open Datasets can kind of give you examples for real application domains with some of the Azure stuff that you might need to work them. So great. I think we're doing good on time. So I'm going to take a minute to tell you one of the most important things. And now this is really a speed round of developer tools. Like I said, keep the repo and watch for blog posts for step-by-step analysis for each one. But we're coming to the point where we're saying, great, you've learned all this stuff. But what is important if you start putting this in practice in the real world? So the next tool I want to talk about is Responsible AI. Or Responsible AI Toolkit. So Responsible AI is this kind of like a set of principles that's trying to safeguard how we use AI in the real world to make sure we do no harm. And that means there are 6 AI principles: transparency, accountability, fairness, safety. how do we ensure that our models, our analysis, our AI algorithms are all being responsible in their usage? And when you think about this, you really want to step back and think about it in two ways. One is I'm using the data to create a model. So I want to make sure that one, the data that I used is fair and covers all the demographics that might be using that model or might be using it or might be forced to take a decision from that model. I want to make sure that the error rate for different demographics is the same, meaning that there isn't one demographic that gets a better deal from this algorithm. And then when I've built this model, when I've looked at the data and made sure that my model is fair and responsible, I want to go this extra mile and say, this is just a model, but that model is going to actually be deployed into an AI system where it's going to have a prediction that's used to make a decision. Am I making the right decisions? How do I debug that? So there's things like decision-making support in this toolkit, where you can do counterfactual analysis. You can basically do what if analysis, say what would happen if I did this? And so that particular site has Jupyter notebooks that you can pull in and explore. And then when we get to this point, this is going to be my favorite thing. All the stuff I've been telling you, use tools, learn the stuff. This is the traditional way. But we're in the realm of generative AI. What if I could take all this away from you and say, hey, just bring your data and ask questions and it shall happen. This is the latest. I mean, this is actually a tool from research called LIDA and one of my favorites. And I would love for you to go explore it from Victor DeBeer and Microsoft Research. And what it is it's an open source project that will visualize the data in a given data file using natural language and large language models. And what it'll do is you don't need to know anything about data. It'll help you understand the shape of the data. It'll summarize the data for you. Say, oh, you just gave me a file. Let me tell you what's in that file. Then let me tell you what kinds of things you can learn from that file. And then let me tell you for anything that you wanted to learn, let me tell you how many different ways you can visualize it. Want to see how that works? You can actually go run the thing. This morning I had issues because there was some problems with, I think it's working now, but you can see the goals running. Yeah. So this morning I had some issues with OpenAI, but you can go check it out. What you need for this is an OpenAI key. And one of the benefits of doing this in GitHub Codespaces is if you go to Codespaces, you can just create a new secret key and then associate it with the repo that you forked into. And now when you launch Codespaces, that key is just available in the environment. You don't need to do anything. But if you're like me and you're using Docker Desktop, just make sure that you make a copy of nCopy and put those parameters in there. But here is what LIDA can do for you. So I put this warning because this morning I had some issues with OpenAI, but I'm just going to walk through what you can do. You just come there to LIDA and say, here is my CSV file. What is it? Can you tell me what the shape of this data is? And it summarizes and says, well, I found these columns, these fields. And so far, this is kind of traditional, nothing new, except that I didn't have to go and use a library. I just asked. But then it gets interesting. Remember, I don't know what I don't know. So I'm like, hey, okay, this is great. I know the shape of the data, but what is it that I can ask? What kinds of insights can I get from this? Generate goals for me. And it comes up with, here are some questions that this data could answer for you. This is cricket. What is the distribution of the first innings? What is the distribution of scores? And not only that, it tells me, hey, for this question, I'll even recommend a visualization and give you a rationale for why that's a good visualization to explain it. And so I can actually build on this and say, you know what? Because this is natural language and it's open source, I can say, but wait, this is cricket. I don't want to know everything. I'm a Mumbai Indians fan. I'm that team's fan. I want a persona set to a person who loves that team. Now tell me what my goals are, and you'll see the goals now change to reflect that persona. Then I can say, hey, show me how to visualize the data. You said that for the goals, I could visualize them. And it says, here you go. Have not done anything yet. I've literally just been asking the library to do this for me. Then I can say, but wait, there's a goal that I didn't see. I'd like you to come up with a visualization for it. This is my query. What's the frequency of task decisions based on team? And says, sure, here you go. So I can, in natural language, did I know what that meant? No, I'm literally asking, how do I get this? And it generates this for me. Remember, Copilot can do this too, but I would have to know how to frame the question. I'd have to know what to ask. And also, if I wanted to customize it, I couldn't. But it's still a great place to start. You just have two options. I can work prompt engineering into the query. Not only can I ask it, hey, I've got my own question, but I can be like, change the color, put this axis, everything in natural language. I didn't need to know the functions. But I can go further and say, you told me these goals, but I want to know why. Why did you pick them? I'm not sure what the explanation is for this. And I can say, hey, I like that question. Can you tell me 4 different ways I could visualize it? So I think I'm almost out of time. So I'm going to kind of wrap up really quickly towards the end. But the goal that I'm trying to say is your journey should be, first, get started with an environment. Then get assistants to help you explore it and be fearless about changing things. Get data, look at the community, learn from them. Make sure you're always thinking responsibly. Then start using generative AI tools to see if you can do this with natural language. And when you get there, you can start thinking down the line about the paradigm shift. All the things we're talking about fit into the traditional machine learning ops cycle, where you're really generating a predictive AI application. But when you're moving to generative AI and natural language, that changes. So do you want to know how to build these kind of apps? Well, you're in luck, because this week we are also releasing a series of 5 posts. You can go to that site, and that'll walk you through end-to-end development of a production-grade retrieval augmented generation app using a Python SDK on Azure AI Studio. So that's yet another thing that you can try out. And last but not least, what can you do next? At this point, if you fork the repo, go haywire. Just go and extend it, add your own packages. Every time you see a tutorial, drag it in there, put a notebook, start playing with it, add the requirements, keep maintaining that environment so that you can continue to learn. So in conclusion, we started with the 3 goals. Make it frictionless, make it focused, make it friendly. We talked about tools that can help us. And with that, I'm going to leave you with the last 2 resources. This is what we kind of covered today. And this is my schedule of posts for the upcoming week. You can go to that URL and check out for a post tomorrow. Or just if you fork the repo, I'll make sure that I update the README with links. And there will be a post a day in that series that will kind of dive into one of those tutorials. And if you want to keep in touch with what's going on in the space, there is also this link to a collection that I set up that I will continue to keep updated with latest tools, tutorials, and more. And with that, I know I'm a little bit over time, but hopefully it was okay. And I missed all the questions. So Don and Sujit, if I missed something, please let me know. And I have a typo, so I probably should not show that. Can you all hear me? Oh, are you muted? You're muted.
No, thank you so much for the awesome session. Everybody was asking if this will be recorded and available afterwards. So thank you for an awesome session. And I think we've been trying to answer some of the questions that were on here in the chat throughout the session, but we did have a few questions that we did want to ask. So as for next steps, you said try it out and go to my repo and then create your own code space. When you're creating the code space, is there a particular compute size that people should be selecting?
Not at all. I actually suggest that you do the code space, the default one, just to get through the exercises that are there. But if you're going to use Docker Desktop, like the way I am, you can scale it up if you start trying to do machine learning things. So for the basic stuff that I'm doing, the free tier of GitHub Codespaces is more than enough. That said, what I would encourage you to do is pick a data set, try looking at different data sets. I'll also park that whole conversation in a corner and say, we love code spaces, but if you want to, there are other tools you can use to go explore this stuff out. Azure also has GPU-based environments that you can look at. But yeah, from code spaces, lowest tier should be fine.
Do you now use code spaces in most of your cases now, or do you ever use your local machine at all?
No, yes, I do. Do you want to know why I have to do my demo on Docker Desktop? Because I ran out of my free tier of code spaces. I accidentally ran out 14 days before. And so I'm like, oh my God, but this is the beauty of it. I'm like, all right, fine, I'll keep on Docker Desktop. And yeah, I use it all the time. That is a good thing you brought up. You can set up automatic kind of guard so that you don't run it forever. Running it there's free quota, but if you use it up, it's gone. But yeah, I use it everywhere. And I'll tell you one additional thing. I use it with my 15-year-old who's in high school, because one of the things you want to do is you want to stop people wasting their time in setup. You want them to get into the learning, right? And this will help.
Awesome. Well, thank you so much for being on here and for answering all the questions.
Sounds good. Thank you all for having me. And I get extra bonus points because I am wearing a Pi shirt for Pi Day.
Yes.
So,
Happy Pi Day.
happy Pi Day. Thanks for having me, and happy Data Science Day to all.